Hello everyone. Today I'll be presenting my submission for this week's task, building an LLM prompt router service. So the goal was to build a service that intelligently routes user requests to specialized AI personas based on their intent. I used Node.js for the backend, the Grok API for ultra-fast LLM inference, and Llama 3.18b instance has the underlying language model. So the core problem I solved is ensuring users get high quality, specialized answers instead of generic AI responses. By classifying intent first, the system acts as an intelligent dispatcher that provides expert level context for every query. So, a real world parallel to this is customer support chatbots, where a single entry point routes users to billing, technical support, or HR based what they type using a specialized system prompt for each department. So the system uses a two-step LLM process. So the step one is classify. The user's message is sent to the Grok API, which classifies the intent into one of the five categories, such as code, data, writing, career, or unclear. So it returns a structured JSON response with a confidence score using temperature and for maximum predictability. So if we increase the temperature, then the create will be increased, and if the temperature is reduced, then it answers the responses with accurate. So, and next step two is route and respond. So, the classified intent is used to select a highly specified system prompt. A second LLM call generates the final response, this time with temperature zero point 0.7 for more natural creative output. So, I choose this decoupled approach because it keeps the classifier fast and deterministic while keeping the generator flexible. It it's also highly modular. Adding a new math expert in the future only requires adding a new system prompt with zero changes to the core routing logic. So let me walk you through the project structure. So here you can see this, right, the server.js. So it is the entry point that sets up the CLI interface. Here you can see. So this is the entry point that sets up the CLI interface, and the router.js stores all the it stores all the core logic for the classification and routing. And the next prompts.js. So here uh, it stores all the expert system prompts and the route underscore login.jsonl. So the logs were routed logs for every routing event for traceability. So here the output here you can see the type data type, like the file type is JSON L. So what is JSON L means? It is similar to the JSON, but the main intent here is it prints in a single line. So the JSON L is represents means it is JSON line. Okay, and the next going yeah now let's look at router. The class wait yeah So yeah, the classifying intent function is the heart of the system. It instructs the LLM to return pure JSON only, and I have added the text cleaning logic to strip out markdown backtakes in case the model wraps it output in code blocks. So the route and respond function. So here you can see that, right? So the route and respond function that takes the predicted intent, fetches the matching system prompt from the prompts dictionary, and generates the final answer. Everything ties together in server.js. Yeah. So everything ties together in the server.js, which reads the user input, passes it through the router, and then prints the classified intent, the confidence score, and the expert response, while simultaneously saving a complete record to JSON underscore log.jsl. So the hardest part of this task was forcing the first LLM call to return a consistently parsable JSON without any conversational filler like here is your JSON. So I ran into two specific bugs. Markdown wrapping. So the LLM would sometimes return JSON intent code. So instead of raw JSON, which broke JSON.parse. I solved this by adding a string manipulation inside classifying intent to strip the JSON prefix and suffix before parsing. So the next intent hallucination. So occasionally the model would return an intent not in my predefined list. I solved this with a safety fallback. If the returned intent doesn't match with code, data, writing, career, the system forcefully defaults it to unclear. So when that happens, the router responds by asking the user to clarify the request, yeah, instead of guessing and potentially giving a wrong response. So a few honest limitations worth noting is the classification being a separate API calls adds some latency. A smaller local module or fine-tuned classifier for step one could speed this up significantly. The CLI interface is functional but basic, not ideal for end users. For the future improvements, I had loved to wrap the services in an Express.js or REST API so a front end can connect to it, and add a conversational memory mechanism so specialized agents can remember context from the earlier in a session. So let me quickly show you this working in real time. So now let me run this in the local. Yeah. So to test this to run this program, I need to use npm start. So this what happens here is it runs the server.js. Yeah. So here you can see like it is asking me the first question, right? So I would like to ask the first question like tell me tell me about javascript. Yeah. So it has given like something it has given the details, basic details about the uh, javascript. Here you can see like the intent code and confidence is one, and it is showing like maximum confidence, and the responses with like here you can see it is showing in the markdown file, right? So if it is an response, then it would be in a perfect manner while displaying this content. So here you can see the entire content, and then next as you can see, the system correctly classified this as a code intent and routed it to the coding expert persona, which gave a much more precise and technical response than a generic AI would. So that's my submission for this week. Thank you. Thank you so much for reviewing it. I'm open to any feedback and looking forward to improve this project. Thank you.